Okay. Okay. We'll start from here. Okay. So the idea is that this is the last diagram, and this is okay. This diagram actually is showing us two different things. This is called it's a state diagram, but it's a state diagram with it has two state diagrams. Okay. The the one in the box is the inner state diagram, and the one on the outside is the outer well, is the outer one. So basically, you start at the outer, right? And right, we always start by the dot, the solid dot, and we're always going to try to end up over here, right? Okay, so first, the outer diagram is is representing the engine. So nowadays not true, but it used to be true, right? That an engine can only be on or off, right? When you drive a car, you could nowadays, sometimes the engine stops at the stoplight, or it's electric, it doesn't, but the way it used to be was your engine was either on or off, and once you turn on the engine, then so over here, this is modeling how the cars used to work, which is that once the engine is on, then you would immediately go to the inner diagram, which is dealing with the transmission. So it's two different things. The engine could be either on or off, and then within the engine on state, you could have different states within that, right? So you start out with engine off, then you would go to the engine on state, and then with once you started the middle, the inside state, the engine on state, the first place you would go would be where? Park, right? And the only way you could leave the engine on state is also if you're in park, right? You can't get out of engine on if you're in drive or if you're neutral or reverse. The only way to get out of this is if you're in park, okay? And then from park you go to neutral. Neutral you can only go to you could go three directions, and then you could go to drive, reverse, okay? So basically, um, you are you're basically going from one state to another, right? Meaning the the transmission is going from one state to another, right? So um, so the way I like this diagram because I believe it's in other words, like let's say you have a person, right? When they're born, when they're 3 years old, 5 years old, etc., right? I wouldn't say that you're going from one state to another every single year or every single minute, right? I wouldn't, that would be like, it's basically more of a different type it's not really let's say a person that wakes up, they're sleeping, they wake up and then they go to the store, they buy something. So you tell me every time they do something different, they're in a new state. Right, that's a little bit, I think, is overdoing the idea of a state diagram. So I think like you could have like a state of, let's say, asleep or awake, you know, maybe active, not active, but I don't think you should overdo it because then it loses the whole idea of being in a state. So this is a good diagram because it only has a few states, which is how I think they should really be. In our book, if you ever bought it or you looked at it, or they actually have another example. Oh yeah, okay, before we do that, let's just go through this diagram. So basically this diagram is saying that you start with engine off, then you go to the only thing you could do is engine on, which is a little bit weird because why can't you just walk out of the car? Which would be over here, right? This would be you leave you leave the whole car. But for some reason, there you have to go to engine on before you could leave the car. Uh, I don't know exactly how this works. It's a little bit weird, right? Because you should be able to go from engine off, there should be a exit the car, right? Anyhow, but the point is though, from engine on, you could go back to engine off, and then from engine off, you go to engine on, or I don't know what this means, or you could go from, this doesn't make sense, right? It says from engine on, you could go, just leave the car. I don't, yeah. So I think it's drawn incorrectly, and this arrow at the bottom should really go over here, right? Once you go from engine off, you could either turn the engine back on or you could walk away, right? That would be the normal way. So I think this is a mistake. So, but the idea is that within the engine on state, these are the possible transmission states you could be in. I just want to show you like an example. Let's just Google state diagram maybe for another example. Um, okay, so UML state diagram. So images and okay, this is does it say? No, that's just uh, okay, let's see what this is. Looks interesting. Okay, so this is um, this is weird. Where's the start? It doesn't tell you. Uh, I don't like that. Uh, this doesn't. Okay, let's try this one. That's weird. Uh, okay, let's try this one. One more. I'll try. Okay, so this is I can't read it. What if this is not right? You know what? I'll look up a specific one. UML diagram of a ATM. I think that's what this is trying to be. Um, uh, let's try this. Okay, maybe this will be good. Okay, so here we are is a uh, okay. So here we have um, okay. So here we have an ATM. So where do we start? Over here, right? And where do we end? Over here. Now this is a little bit actually it's putting actions instead of states, so it's really not such a, I don't like it so much. But anyhow, the idea is you start over here, you read the card, the machine is in the reading card state, and then it becomes a reading the pin state. Then you choose your transaction state, which I guess that makes sense. And then you could go either, it could either, if you cancel, it could either reject, or you could perform the transaction state, and then you could again do another transaction, or you could just get out, right? Does everybody see how to read that? So we start on top, right, where the machine is reading the card state. And then if it does that correctly, it goes into the reading the pin state. It's waiting for you to enter the pin. And then if you did it correctly, then it goes into, you choose what you want to do, deposit, withdraw. Then it does it. And then you go back from here. You could either be done, right? Or you could go do another one. Yeah.
So unlike in some of the other ones we looked at, you don't need the diamond to say you're making a choice. Sometimes you just have two different arrows that can then be implied. There's like text near them.
Yeah, this, right, state diagram doesn't have time. It's not telling you the process, it's just telling you the states of the ATM. like the possible states it could be in. It's a little bit weird because these are verbs. It's not really like you have to say it's in a reading card state. That's what I don't like about that. See, here it makes sense. It's in the choosing transaction state. Uh, I guess maybe you could say whatever, but that's how they're doing it.
Did you like switch the word order, like the pin reading, the card reading, the card ejecting state?
Yeah, yeah, you're right. Something like that. Right. Very good. Right. So, yeah, that's why, yeah, in our book, they have like this, well, I don't know about the new book, but the old book, he has like, he, it really is not a state diagram. I mean, he really, um, I'll just show you what he did for, he like, he made like a microwave, the whole thing be a state. So he did like, um, chapter 5. Uh, 5. Uh, Okay, so he did, where are we up to? Oh, yeah, so he did this. Where is it? So, no, I hate that one. Uh, like over here, he made a microwave into into like a whole thing be a state. So he made like you could be a full power state, a half power state, a waiting state, a set time state, so it's a little bit not, it doesn't sound right, right? Like I'll give you an example. Like I know it's a good example. Um like a water state, that would be perfect, right? So like water could be um that would be a perfect idea because the water could be only in three could be in 3 states or 4 states. I'm not that good in physics, but you could either be a plasma, water vapor, ice, or liquid, right? So that makes sense, right? Water, it transitions, and you can't go from to plasma unless you first become a water vapor, and you could go from a liquid to frost to water vapor. That actually is wrong. Does that make sense? You could go from ice to water vapor?
Yeah, it's deposition.
What? What does that
It's
mean?
deposition. It's a way to go directly from a solid to a gas.
You could really?
Yeah.
Without becoming water? Wow. Okay, I learned something new. I always drew the water is like, 1, 2, 3, like you have to go. Okay, and condensate. Okay. Okay, that's cool. So you could actually, but you can't go into plasma until you're in the water vapor state, right? Okay, so this I like, right? Because it makes sense. It's one thing and it's changing state, right? But the other one, like they do in the book, is a little bit, I think, a little bit, like they're taking actions. It's really a process diagram, and they're making it into a state diagram. Uh, Whatever. Okay, so I think people overdo it. Um, okay, so we're done with chapter 5. Okay. Or is it 6? This is chapter 5. Okay. Um, okay, so next chapter is let's see what I forgot to order. Okay, so the next thing we're going to do is chapter 6. Okay. So, by the way, chapter 7 we're going to skip because that's basically we've already done that with the design patterns. Okay, so we're up to chapter 6, and here we're talking about architecture, right? Remember we talked about design, software design, and architecture. So, just to give you a simple idea example of what computer architecture is, right? So every website is an example of what type of architecture. What's the word for that? Very good, right. right? There's a client, which is what? The browser, and the server, which is some web server, right? And nearly probably all databases are the same, right? You have a client reading the data or requesting data, and you have a database server, which is sending you the data, right? Or probably all email is client server, right? You 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 have a mail, email server, right? And you connect, let's say, to Gmail, and it gives you your mail, right? You request your mail, or you request it to send your mail. So those are all examples of two different programs communicating with each other, right? So that's all client server, right? But there are other architectures also. So another architect, well, I mean, well, even within, let's say, client server architecture, right? Within the client, for example, you could have a different architecture, a different type of pattern, architectural pattern. So, for example, over here would be that this is like typically like most, the reason I put this here is because most programs that I've been in, that I've been working on throughout my, I guess, career, you want to call it. Most of the programs that I've written or worked on have been desktop applications, and nearly all of them follow this design, which is the three tier pattern. Okay, what are the three tiers? Well, one would be the screen. The middle would be the like the business logic, and then the bottom would be like the database layer, right? So you actually find this in like nowadays we find that, right? We find that there's some people who are what are they called? Uh, gra gra graph, what do they call graphical artists? What's the word? That they design like websites for you. They're called yeah, yeah, graphical designer. Uh, and then if so that they would, for example, work on this layer, and then you have other people. Well, it used to be more complicated to use databases. So you would have another people would be, their job would be to take care of the database, right? They would make sure it's running efficiently. They would make sure the indexes have been built, blah, 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 right? They'll make sure it doesn't run out of room, right? So, because the database to be efficient needs a little bit, you know, need somebody to babysit it, right? Nowadays, they're a little bit better at it, but you still need babysitting, right? So, and then you would have people in the middle layer would be those people who understand what the program should do, right? So you would have like three different skills in a way, right? That the top skill would be what users, what they like to see, right? I mean, what's intuitive for a user to use. The bottom layer would be how are we going to save the data, like, make sure we save it in tables that are normalized and all that stuff, right? And efficient and all that to index properly, and we don't have bad data and all that. And then the middle layer would be the how it should work, right? Like how old you have to be to, let's say if it's a accounting program, how old do you have to be to, or is there an age limit? Like could somebody 5 years old pay income tax? I don't know. But like, the rules of the program, right? How does it work, right? So that would be, most of the people would be in the middle, right? You wouldn't have that, you wouldn't have too many people doing the database and the graphical part, right? But it's split up that way. And in fact, if you look at, let me see if I can bring it up. They actually, Visual Studio actually, which is what I work with in C Sharp, they actually like, oh, I actually have an example here. So if you look at Visual Studio, they actually have like these three divided up. So did it open up? Oh, here it is. I just wanted to show you like example of that. So over here, for example, in Microsoft C Sharp and also a lot of other tools, not in Java, the one that, not IntelliJ, but um, over here you would have one file which is just the design, meaning where all the how it looks, and then you would have another file associated with it, which would interact with what happens when you um, what happens when you click a button, right? So over here would be the business logic, right? When you click the button, right, what should happen? And then you have another layer. I guess the other layer you have to create yourself, which would be the database layer. Well, I just in real life, the database layer would be another program, right? Uh, Over here, I just created a file called database. But so this would be an example of a three-tier design, right? So if you click over here, for example, um, you could design the screen, but the design of the screen does not impact the code underneath it, right? So in other words, whether I want to make this let's say I want to make this button big, right? I want to make it, or whatever it is, it doesn't affect what's going to happen underneath that, right? So the graphic designer could change this screen any way they want. They can make it bigger or wider, right? But that has no effect on the code underneath over here on the database logic, right? Because over here, the logic over here would be the same, right? When you click that button, this is what happens. And it has no effect either on the capabilities. In other words, the stuff we do at this layer has no effect on how this works, how the database is going to work, right? The database is a separate layer. So we could change the logic all we want, but we're not going to affect the database, how that works. Does that make sense? So, so what's really cool about this is, if you notice the way I set it up, what's really cool is that when you change if you have somebody change the screen, it's not going to have any effect on it. You can't break anything else. Meaning that if someone messes up on the screen, you don't have to worry that maybe they messed up the middle layer, right? And if someone messes up the middle layer, right, you don't have to worry that they messed up the database layer, right? Because the database layer is at the bottom, right? It's not dependent on the layers above it. But if if you change the database layer, that could affect the application layer. And if you change the application layer, that could affect what's going to happen, what the user sees, right? Usually it won't, but it could theoretically, right? So in other words, like for example, um, let's say the application layer will give, let's say, all the possible loan terms that you could do, right? So if there's if the if they make a mistake in the middle layer, then the wrong loan terms will show up on the presentation layer, right? So so basically the way it works is the thing with the least dependencies is at the bottom, and then the thing with the most dependencies is at top. So the breaking, so if I change the database, I could break everything above it, but if I change the thing at top, I'm not going to break anything underneath it, right? Right? Because because everything is dependent on the bottom layer, but the top, right, but the top layer, one more time. Everything's dependent on the bottom layer, but nothing is dependent on the top layer, right? Right, the top layer is on its own, right? Because it won't, if you change the top layer, it's not going to break anything. It can't break anything underneath it. And but if you break a layer in the middle, let's say you have 5 layers, right? So if I change layer 3, let's say 5 is the bottom, 1 is the top. So if I change layer 3, I could break 2 and 1, right? Theoretically, right? Hopefully, I only going to break 2. I only could break 2, but it could be, it could boil all the way up, right? But but you don't have to worry about the layers underneath it. So if you change layer 4, let's say layer 2, and 5 is the bottom layer, you don't have to worry about 3, 4, and 5, right? So that's what's nice about that. I mean, okay, so that's one benefit of having a layered program is that you have like this, you don't have to worry, you worry less about breaking things, right? Depending on what you changed. Another thing is, like we just mentioned also, is that the program is naturally divided into 3 different parts, right? You have you have the people whose skills are design, they would do the top part. People whose skills are working with databases, they're going to be at the bottom. They'll be working on that layer. And then people who know how the program should work, they would be in the middle. So that's another reason to have a 3-tier because it allows different uh, different types of people to work together on the same thing, right? It's a natural way of dividing up the work. Okay. Um, so the first thing, I took this from the book, but it's a very good idea, which is that the first thing you want to do is when you design an application is you look around and you see how do other applications, how are they designed? Okay, so for example, like we know websites are client server, right? We know, for example, um, that let's say uh, operating systems usually have one command could go into another command, right? Like like especially with Unix, right? You could take the output of one command and send it to another from one program or command to another command, and then and so on, right? So those are the ways that so different architectures, or for example, a um, let's say for they're like, for example, let's say you go to a website, right? The architectures nowadays, if you go to most, let's say, um, let's say most, let's say you go into Amazon, right? Well, actually, Amazon's different because, but like, let's say you go to, let's say, I don't know, the CIA website. Chances are I can't do anything until I log into the CIA website, right? If you go to Amazon, you don't have to sign in. You could just look at their products, even if you're not a member. But many, like most things, require you actually, let's say you go to email, you can't just search email. You have to sign in as somebody, right? So there's a certain way it's designed, meaning that there's a security layer around it that you can't do anything until you've been um, authorized or authenticated by who you are, that you're a person who's authorized to, you authenticate who you are, and then you're also authorized, right, to enter, right? You know there's a difference, right? There's authentication, which means I am who I say I am. And then there's another thing called authorization. Do you have permission, right? So, let's say to go in the CIA program, you might need both. Not everybody who is, just because I know who you are, doesn't mean you could come in, right? So, their architecture is secure, meaning you can't do anything on the website until you authenticate and we also check to make sure you're authorized, right? Whereas Amazon, you could get in, you just can't buy anything, or maybe you could even if you don't have a login, right? Some websites you could buy even like as a guest, right? You don't have to sign in altogether. Um, that's the idea of having different architectures. Okay, um, so over here I showed you three-layer architecture, but you could have multiple layers, right? Like for example, I know in let's say networks, there's like 8 layers of. Does that sound right? There's like 8 layers in a network, right? In a let's say a network messaging track, there's like a bunch of layers, right? There's a session layer or this layer, right? They're like TCP/IP goes over. There's like it's divided into many different layers. So um, so you could do more than 3 layers, right? As many as makes sense, I guess. Okay, so first of all, this is what I said before, which is that when we change a layer, all the layers above it are going to may need to be retested, but the ones underneath it do not. Number two, when we have layers, it helps us divide the code by like I shouldn't say by what it does, by what employees do, right? So different people with different skills can work on their own layer without disturbing people working on the other layers, right? Okay. Um, Number three, each layer is able to be tested separately because they're not mixed together. Okay. Meaning that theoretically, um, right, each layer has its own test that you could run on it and just test that one layer. Um, and number four is that because if it's really done well, you could just swap one layer with another layer. So for example, over here, I could change the database at the bottom, right? As long as I have the same methods, I could just swap the database layer or the other way around on the screen, right? Instead of, let's say, being I could just swap out the screen from being, let's say, a Windows screen to, let's say, a smartphone screen, right? Or iOS or something like that, right? Or Android screen. Um, so I could just swap out different parts if it's really well designed, right? If this layer only has the presentation stuff, then it's really easy to swap out and just change your application real quickly, right? Um, okay. Now over here, I just wrote down that I don't know why I picked it to say it here, but I just quickly run through things that are specific to web applications. Um, Number one, everybody knows about is security because um, because basically you're on the internet, so everybody has a chance to attack you, right? Um, by the way, do you know how to get around this security issue of being on the internet? You've heard of it? It's called air gap. You've heard of that? What? Right, air gapping, and the idea is that you're not connected to internet, basically. That's why it's called air gap. Uh, so, but they figured out ways to get around that also. Like they could put a virus and they could put something on one computer and it could like make noise and another computer could like listen to it. So it could go through the air gap. Uh, and Yeah, and there are other ways like because even if you have an air gap, there are times when you have to, like upgrade the operating system. So when that happens, somebody could, you know, could do something to you, right? So nothing is totally really, you know, free, secure. Um, okay, number two is that you're relying on the web browser for the security, meaning that you basically aren't in charge of the security because, someone's connected to your website, they're going to go through their own browser. Um, Number three is that you have to you're dependent on the internet for speed, right? That's another issue, right? Because let's say you're on an airplane. I don't know if you've ever tried using your laptop in an airplane, but it gets very iffy, right? Sometimes it works and it doesn't work. So you have to know that the internet's it's not always going to be good, right? It might be fast, might be slow, might stop. Like you're on the train, there's internet between stops. But like as soon as the train moves, you're out of there goes your web, your internet. Um, Number four is that the way the regular websites work is if you use regular HTML, it's very ugly, right? You have to like make it interactive, right? You need some to make like the screen to move and stuff like that. You have to add something, right? Because otherwise it's just, doesn't look very nice, regular HTML. Um, Number five is you can't control I don't know what I meant by that. Uh, I'll get rid of that. Okay. In a web application, you have to remember, oh, this is very important, is that by definition, the way HTTP is designed is that it's called stateless. Have you ever heard that before? Which means that by default, if you go to a website and let's say you ask for, let's say Amazon, show me what's on sale for Black Friday, and they send you a list of 50 things, right? Right? But so if I say, let's say, I want item number two, it doesn't, by default, it won't remember what it sent you before, right? It's basically, it has like completely, it has no memory, right? So it's like ChatGPT, you ask it a question, I think regular doesn't remember, does it?
But if you have the paid one, you could ask it to remember certain stuff.
Say again,
If you have like the paid version, you can ask it to
oh,
remember.
paid version, right. But if you're on the unpaid version, it doesn't remember,
Not as much, it's
Uh,
like half.
it remembers a little bit?
Yeah.
Oh, okay. I try not to use ChatGPT, so I try to stay away from it. I think it's horrible. And that's my opinion. Um, I just think that ChatGPT is like the time it takes you to figure out how to ask it a question, you could have learned whatever you were asking it to do. Now, I mean, you're not asking a question, you could, what?
Prompting it.
Like I was once sitting in at work, they had this class how to ask ChatGPT to do things. And like one of the ideas was ask it to write, let's say, three letters, and then you pick which one you like. And I'm thinking, well, why can't you just spending all that time reading three different letters and to try to like just learn how to write? Like, is it so horrible to learn how to write? So I don't see the benefit of it. It's like, and yeah, I don't get it. Like, why can't you? The amount of time you spend playing around with it, you could just learn how to do something, and then you know how to do something. You don't you don't gain anything from asking someone else to do it for you, right? That's my opinion. You don't grow. You just, you're the same person you were before. Before you asked to do something and that did it for you. Okay, but now what? You didn't grow. You're not learning. Um, okay. So anyhow, but that's a problem with state, meaning that there's a lot of issues with states. So to get around that, that's why I think we have how do websites get around state? Do you know how they do that? Right? So they're different. There are a couple tricks. One of them is they use cookies, right? For local storage, right? Um, but okay, but that's an issue. Okay. Now another thing about websites is, let's say Black Friday is coming up, right? So we know that Amazon is going to be pounded, right? Right? They're going to get millions of people looking for Black Friday deals, right? So, um, so, but if they're using, let's say, a SQL database, right? So all those, even though it might have, let's say, keep on spinning up new servers to handle all the traffic, right? But the underlying data, right, is is prone to bottleneck, right? Meaning that even though you could make multiple web servers, spin them up as you need it to handle traffic. But let's say if you have a commerce site, right, which has to keep track of um, how many items you have available, right? So there's like a bottleneck, right? Because if someone's buying 200 vacuum cleaners, then there's not going to be anything left for the other people. So even though you have all these servers all over the place, but the data has to be like, well, at least in SQL Server, has to be stored in one location, one table. So you could have a bottleneck by that. So that's also another issue. How do you take care of the database bottleneck, right? Um, Okay, 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 and that's that for, I just threw that in. This is really nothing to do with the rest of this chapter. Okay, now this is actually very interesting, that what determines the architecture of a system? Okay, so most people would think, well, what does it need to do? Okay, but according to the book, and it makes sense if you think about it, is that the non-functional requirements determine how it's going to be architected. Meaning not what you need it, what you think you need it to do, but rather the background functionality. Meaning, for example, like they give a bunch of examples. So, for example, let's say performance, right? Performance it should be quick, right? So that is a functional or non-functional um, requirement. I'm sorry? Non-functional, right? Because it's a generalized thing. So then that determines if you need performance, so then you shouldn't have your program spread out all over the place. Meaning that it doesn't mean I don't think in the same like project, like software project. It means like you shouldn't have, let's say, some of the data in the cloud, some of it over here on a different cloud, and you're like combining data from all different sources, right? But that's since the sources are all over the place, right? You're not going to get good performance, right? Right? Like, for example, imagine Tesla would, while you're driving, would speak to Tesla.com and decide whether it should make a left turn or a right turn or stop or, should it stop or not, right? That's not going to work out very well, right? Because if you need quick decision making, you can't wait for a internet connection to, go to Tesla and then decide yes or no. Should I stop? You're right. You can't rely on the internet for that, right? Because, so everything has to be in that car, right? Or in that computer that's driving the car, right? You can't wait around. You don't want to, um, you don't want to, you want to be as quick as possible, your decision. Um, Okay, so, oh, and then we have another example of, let's say Alexa, right? So Alexa, how's that work? So for Alexa, do I have a picture? of it? So if you actually, it's actually the architecture of Alexa, you could look it up. It's over here. And, okay, we're nearly done. Um, there's not much more to this chapter. We'll be done soon. So, I mean, well, we're not going to finish up today, but so for example, look in images. So if you look over here at the Alexa, no, this is, oh, here. Okay, so over here, like it'd be give you an idea of how Alexa works. The way it works is that you have your device over here on the left, or on your right, I guess. And then the way it works is Alexa has no brains, right? All it does is listens to the words, "Hey Alexa," right? And then when it hears those words, it sends your language to the cloud, to Amazon, right? And then Amazon does whatever it does and sends back a response, right? So it goes over here and then it goes back to the device. What should happen? Turn on the lights, right? But the device itself over here doesn't really have much brains, right? But over here, so this is not going to have great performance, right? Say, hey, Alexa, turn on the light. It might take a while before it goes back and forth to the cloud. But you don't care because it's not life critical. No one's going to die if it takes a second or two to turn on the light, right? But so this architecture could be spread out, right? Because we're not worried about performance, right? But like if something is we're worried about performance, so then it has to be right. If like a Tesla or a self-driving car needs the information right, it needs to act right away. It can't wait to get to speak to a cloud. Um, and okay, and then let's do one more thing is security. So security, we actually explained that if you're worried about security, meaning that you don't want people to, come to you, look at your data. So then what you want to do is you want to have just like, in Queens College, where's the security in Queens College? It's not on the building or not in the room level. Where's security by the perimeter, right? So, but mostly nearly every secure website, you need to pass the outer layer to get in. And once you're in, then you're in. So just like Queens College, once you're in here, you could, there's really not that much security. But you have to be able to get in to the outer layer. So that's a basic architecture of many websites, which is that there's a outer layer of security. You have to sign in, log in, authenticate, whatever. And then once you're in, then you could do, you could do stuff. So the outer layer would be security. Okay, so we'll finish up. There's not much more actually in this chapter. Okay, so we'll finish up next week, I guess. Okay. And then we're gonna skip chapter 7 because like I said, we already did that with design patterns. And then we're gonna do chapter 8, which is testing. And that's pretty much it for our semester. Okay. So, okay, so I'll see you. Okay, see you next. Have a happy Thanksgiving. And let me know if there's anything good to buy.